Alright, so this is going to be a video on the periodic table. This video is going to be answering the questions, how are elements arranged in the periodic table, and what are some trends of the periodic table? So we discussed how the periodic table got its shape in a previous video, so let's go a little deeper on the implications of that. The periodic table you are used to seeing is not actually how it really looks. If you notice, the periodic table has two rows of rare earth metals called the lanthanides and actinides below it. You will often see arrows or lines similar to these. What this is supposed to be showing is where the two rows are supposed to be. If you look at barium, Ba, you should notice that the atomic number goes right from 56 to 71. The reason for this is that elements 57 through 70 are located on the bottom with the lanthanides. The same thing happens with radium, Ra, right below. The atomic number goes right from 88 to 103. Elements 89 through 102 are also located at the bottom with the actinides. The reason that the lanthanides and actinides are transposed to the bottom is that they are not used as often as the rest of the elements, and also the fact that the periodic table would look something like this if they were included in it. This is not exactly easy to read or use, so this is why the periodic table has the lanthanides and actinides pulled out and moved to the bottom. The first two columns are then moved closer to the other columns to end up with the periodic table that we are used to seeing. Let's break it down some more. The periodic table is broken up into periods and groups. Periods are the rows and groups are the columns. An easy way to remember this is that periods are at the end of a sentence and sentences go from left to right. Groups go up and down in columns, and the word up is in the word group. Let's break these down a little bit more. Elements in the same period have the same number of electron shells. This will be important to know when we start discussing periodic trends. The period number will also tell you how many shells each element in that row has. Row 1 elements have 1 shell. Row 2 elements have 2 shells. Row 3 elements have 3 shells, and so on. Elements in the same group have similar but not the same properties. As discussed in the previous video, this is because elements in the same groups have the same number of valence electrons. If you remember, valence electrons are the electrons on the outermost electron shell. Because elements in the group have the same number of valence electrons, they interact with other atoms in a similar way because the outer shell is what other atoms would interact with first. Because elements in the same group have similar properties, groups are sometimes called families. Like a family, members of the group have similar properties but are not exactly the same. Each group or family also has a name. The first column is called the alkali metals. Hydrogen is not included in this group. The second column is called the alkaline earth metals. The next 10 columns are all going to be lumped together to be called the transition metals. The rare earth metals of the lanthanides and actinides are also going to be lumped together. The next column is called the boron group due to the fact that boron is the first element in that group. The same pattern occurs for the next few columns, simply being called the carbon group, the nitrogen group, and the oxygen group. The next group is called the halogens, and that last group is called the noble gases. After a quick glance of the periodic table, you should be able to see a trend quite easily. Metals make up the lower left side of the periodic table. Nonmetals make up the upper right side of the periodic table. Metalloids almost make a border between the metals and nonmetals. The difference between the three is as follows. Metals are generally characterized as being shiny, relatively good conductors of both heat and electricity, solid at room temperature, malleable, this means they can be bent, and ductile, which means they can be drawn into wires. They can also relatively easily lose electrons, becoming positive ions called cations. Nonmetals are generally characterized as being the opposite of metals. They are not shiny. They're relatively bad conductors of heat and electricity. They are usually gas at room temperature. They're brittle and can easily gain electrons, becoming negative ions called anions. Metalloids are generally characterized as having both metal and non-metal properties. It's important to know that there is not a general consensus about what constitutes a metal, non-metal, or metalloid, as some metals and non-metals exhibit metalloid properties in certain circumstances. So you might be thinking, who cares about the periodic table? Well, if you ever go to a chemist's or some other scientist's lab, you will probably notice a periodic table hanging up somewhere in the lab. The reason for this is that the periodic table is basically a cheat sheet for scientists. Rather than having to memorize atomic numbers, atomic masses, orbitals, trends, etc., the periodic table can show these things in a nice, neat, compact way. This can help scientists, namely chemists, do what they do best: understand matter at the atomic level and design matter using atomic properties. So that's the periodic table. If you have any questions about anything in this video, let me know.